Welcome back, everyone. So to answer this question that we're obsessed with this week about the fate of the universe, we first have to understand the idea of the Big Bang and why we even consider the Big Bang to be true. So let's start with the most important, the first piece of evidence that led to our thinking about the Big Bang, which was what's called Hubble's law. Recall from our first week the idea of Doppler shift, that if we see light from an object being having its light stretched so that it be, if we have something that we know the wavelength, what the wavelength should be, and we see that wavelength stretched out, we know that that is a red shift and the object is moving away from us. If the light is compressed and the wavelength goes down, that is a blue shift and the object is coming towards us. Well, it was in the 1920s that Edwin Hubble went out and started making measurements of redshift or blue shift of galaxies, and what he was astonished to find was that everything was redshifted. With the exception of just one or two cases, every galaxy he looked at was moving away from us. And so all the galaxies were moving away from us. And not only that, the speed at which the galaxy was moving away from us depended on how far away it was from us. So by making independent measurements of distance and combining that with the measurement of the galaxy's redshift, he found there was what's called a linear relationship. The farther away it was, the faster it was moving. And that's called Hubble's law. And this was one of the most remarkable discoveries in the history of astronomy, because what it implied is that the entire universe was expanding. Not just the galaxies, but space-time itself was actually stretching, and the galaxies were just sort of like, you can imagine them to be marbles pinned onto a rubber sheet. And as the rubber sheet was stretched, the galaxies are just going along for the ride. So this was the first indication, essentially, that the universe was expanding, that there was something we could call a Big Bang. So, you know, if you imagine putting raisins inside a loaf of raisin bread of dough, and then putting it in the oven and allowing the bread to expand because, of course, of the yeast, every raisin will move apart from every other raisin. So no matter which galaxy you're sitting on, you would see all the other galaxies moving away from you. So this was our first indication that something like, it was our first indication that the universe was expanding, right? So how do you get a Big Bang from this? Well, if you run the movie of the universe's expansion backwards, then what you'd expect is over time, things that are very far apart would end up being very close together. So it was clear from this, well, it wasn't exactly clear. We took a few more pieces of evidence for people to really understand this, but at least the implication with the discovery of the Hubble law was that the universe early on must have looked different than it does now. The universe was not static. The universe was not eternal in its appearance, that there was an earlier epoch of cosmic history that was very different from our own. So using Hubble's law, you can actually figure out in a simple way the time that it would take for everything to be very close together. And what you end up with is the naive use of Hubble's law. You end up with a cosmic age of about 14.3 billion years. So that assumes there's in that calculate. It's a very simple calculation. As we'll see, that's not the actual age of the universe, but it's pretty close. So even a simple calculation gives you about 10 billion years of cosmic history. What comes with the understanding that the universe has evolved is that if we look at a galaxy 7 billion light years away, we're really looking halfway back to the beginning of the universe, right? That's what's really remarkable. Once we come to understand that the universe has a history, when we're looking back, when we're looking out in space, we're actually looking back in time and history. So that's what comes when we understand the universe is not static. All right, so the idea of the Big Bang is that the universe started from a hyper-compressed state, that all the matter in the universe was densely packed. Now, to understand what this means, we have to understand what the Big Bang is and what it isn't, okay? The first thing is, the Big Bang is not a theory of how the universe began, how time began. It's a theory of what happens immediately after the universe began. It's a theory of after, because we're going to use the laws of physics that we understand, and we're going to track as far back into this hyper-compressed, high temperature state as we possibly can, and then let time begin to run forward. But what actually happened when the universe, what actually created that state of the universe is not science. Right now we can't answer that question. Maybe we will be able to soon, but right now we're not in a position to really answer that question definitively. So the Big Bang is a theory of what happened after the Big Bang. It also tells us how the universe evolved. It didn't tell us why the universe is there, right? Again, so this is, you see with cosmology how this is a science that's really bumping up against very deep philosophical issues, and if you're so inclined, even theological issues, okay? The Big Bang is our creation story, right? It's our narrative of how the universe evolved and emerged to become what it is today. And it's still, because it's a scientific story, we see changes in it. The basic narrative has not changed now over 60 years. Our understanding of what immediately happened after the moment of creation has not changed. But you know, we've been adding to the story as we come to understand more facts. So we have really firm observational evidence for a lot of this story. But when people begin talking about what happened before the Big Bang, or you know, the idea that there's multiple universes, that stuff is still very much scientific speculation. We don't have any evidence for the existence of any other universes, or we don't have any evidence for what came, direct evidence for what came before the Big Bang. So it's important to understand where the science is very firm and where scientists are still, coming up with new ideas and hoping to find something that might have an observational handle on it. Okay?